I am Kiriti Sahu, a professor in the Department of Chemical Engineering, IIT Hyderabad. In collaboration with Dr. Saravanan Balaswamy and Dr. Sayak Banerjee from the Department of Mechanical Engineering, IIT Hyderabad, we have developed a theoretical model to predict the lifetime of SARS-CoV-2 droplets. Our simple but effective theoretical model is capable of accurately predicting the evaporation time of saliva droplets. COVID-19 spreads primarily by respiratory droplets of size greater than 10 micrometers of saliva or discharged from the nose of an infected person during coughing and sneezing. Fluid dynamics can play an important role to study the lifetime of these droplets. We investigate the effect of ambient temperature, relative humidity, size and composition of saliva droplets. Saliva droplets not only contain water as a major component, they also consist of salt, protein and surfactant. These ingredients delay the evaporation of respiratory droplets significantly as compared to pure water droplets as considered in earlier studies. We found that while the lifetime of a small saliva droplet of size 1 nanoliter is less than a minute, a normal size saliva droplet of 10 nanoliters takes more than 15 minutes to evaporate at room temperature and relative humidity of 50%. For higher relative humidity, say for greater than 90%, a typical droplet stays alive on a surface for significantly longer time, about an hour. We encounter a large change in temperature and humidity across our country as we go from one state to the other state. The longest drying times are observed when with the combination of low ambient temperature and high relative humidity. The time taken by saliva droplet to dry up also depends on the nature of the surface on which they fall. We found that for a fixed initial volume of the droplet, increasing the initial contact angle, which depends on the surface they fall, increases the drying time. For instance, under the same environmental condition, the drying time of a saliva droplet on a smartphone screen is 3 times longer than that on a normal glass surface. In general, highly hydrophilic surface may be less susceptible to prolonged contaminations in comparison to less hydrophilic surfaces. This is somewhat a counterintuitive result from our study. Overall, our study shows the importance of properly sanitizing the contact-prone surfaces in different seasons and indoor areas. For example, when we use an air cooler in summer, it sprinkles water droplets and thereby increases the humidity and decreases the temperature inside the rooms. This type of condition is very prone to increase the lifespan of these droplets. Of course, our study can be taken off to the next level by considering the biology of this virus into considerations. Thank you very much.